We're going to go ahead and look at the volume form by taking our parabola, which is opening to the left, but moved 6 units to the right, and that's what we have here, being curved around. And we're going to look at our line right here, which we have going down diagonally. And we're going to look at y equals 0, which is our horizontal axis, which is here in dotted blue. So we're going to look at the shape that's formed by that, which is right in here. And we'll be taking that shape and we'll be revolving it around the vertical line x equals 1, which is here in orange. So we have this outer part, we're revolving it out and around, back through the screen and around. We have this hole in the middle. So that's a washer thing. It's a vertical axis of revolution, and with the washer, that's dealing with y. So we have our y's here. So our bounds for our integral need to be the y values for the top and bottom of our shaded region. We're starting out at 0, so our lower bound is going to be 0. Our upper bound, where the two curves meet for the top of the shaded, is at a height of 2, so that's going to be 2. Then we got to go ahead and take a look at our outer radius, the big R. That's what we're going to put here, and that's what our big outer radius is. That goes from what's on the right, which is our function, to what's on the left, which is our axis of symmetry. So we got to take what's on the right, our function in terms of y, minus what's on the left, which is our axis of symmetry. And that's our outer radius, and we need to go ahead and square that. Then we need to go ahead and take a look at our inner radius. Our inner radius goes from just the right side edge of left side edge of our hole, well, left side edge of our shaded region, to our axis of symmetry. And that's what we're going to be looking at here, and that's what's going to go here. To do that, we got to take what's on the right, which is our line in terms of y, minus what's on the left, which is our axis of symmetry. And then we need to square that because of our formula over here for the area of this disk that we're getting rid of in the middle. So this does simplify down. We have our pi in front. First set of parentheses, 6 minus 1 is our 5. Oops, wrong one, sorry. There we go. And then we end up simplifying the second set of parentheses. To finish all this out, you'd have to just go ahead and FOIL this. Combine your like terms. Increase your exponent by 1. Plug in what you get when you put in 2. Subtract what you get when you plug in 0. And then you get 3/16 pi over 15. Now, pretty much from this line right here on down can easily be done on your calculator. If we are here, we can go math, then we can go to number 9. And, oops, it's just being putsy, sorry about that. Then we can actually type in our bound of 0, our upper bound of 2. Then inside the parentheses here, we can type what we have inside the square brackets right here, and then we can go dx. So if we do that, we would get this. Then I could turn that into a fraction by going math, enter, enter. And I would get this here. I know there's a pi in front, so I got to have a pi with my answer. So I would get my 316 pi over 15. But it's easier to do it with your calculator that way.